a TI-84 Plus. This one's the silver edition. The methods that I'm going to go through is also the same for the TI-83 that a lot of other classes use. What we're going to do is we're going to do a linear regression. And I'm going to do it on problems 3, 4, and 5 on your homework, on the homework for activity 7 that we're doing in my class. So Jen & Barry's ice cream shop has tracked its ice cream sales and compared them to the daily high temperatures. The table below displays the high temperatures for the 10th day of every month last year and the quantity of ice cream sold that day. Of course, we have our table here. We have our months, January through December. We have our temperature, and that's Fahrenheit, the degrees. So in January, it was 39 degrees on the 10th day of the month. And then the amount of ice cream they sold. So in January, they would have only sold 12 gallons of ice cream when it's 39 degrees outside, which makes sense because I wouldn't want to have ice cream when it's cold outside. So number 3 says, make a scatter plot of the data and label your axes. Now, of course, I want you to do this by hand, but I'm going to show you how to use the calculator for this. First thing you want to do is go ahead and turn on your calculator. What you need to do is you need to go ahead and put in your temperatures, your X's, and your ice creams for Y's. And the way we're going to do that is you're going to go to Stat, you're going to go to Edit, and you see I already have them put in here where I have 39 as the first term. If you look right here, L1, this means first term is going to be 39. And as I go down, you'll see I have 12 entries, meaning 12, L1 of 12, this is December, is 51, which is this term right here. Then I put the corresponding numbers in my L2, which are going to be my Y values. You can see that in list 2, the first month, January, is 12 gallons with this one. Now, what's really important is when you go to do these regressions, you want to make sure your list 1 and list 2, they both match up. So list 2, I have 12 items. In list 1, I have 12 items. You'll get an error if you're one item off. So if one has 12, the other one has 13, anything kind of goofy like that, you'll get an error. Now, let's go ahead and turn on what we call the correlation coefficient. Your calculator is going to show it as an R. What's nice is on this one, you could just go to Mode, and you can scroll down to where it says Start Diagnostics. Right now it's off. You can just turn it on. However, if you have the TI-83, it's a little different. You don't have that in your mode. So what you'd have to do is hit Second, Catalog, and it's under D for Diagnostics. So you're going to find D in the green, the letters. So here it'll shortcut you down, and you want to scroll down till it says Diagnostic On. So right here you see Diagnostic Off, Diagnostic On. We want to turn it on, so you're going to hit Enter, Enter, and when you see Done, now when we run our regression, it's going to give us our correlation coefficient, basically telling us how well does our data fit to be a line or a cubic or a quartic, if it's a median line, something along those lines, whatever regression we do. So number 3, it asks us to make a scatter plot of the data and label your axes. Well, you have to have everything, you have to have your stuff in list 1, list 2, which we already did. And in blue here it says stat plot, because this is statistics. Hey, it goes with stat right here. The stat button, stat plot. So we want to hit second, y equals. And we're going to go ahead and turn on. So you want to hit enter on stat plot 1, and you'll turn it on. Now in here you can do a couple different things. You have different choices of types. You have box and whisker, you have bar graphs, I believe maybe just a histogram. I've never really used it on this calculator. But here's what's important. My X values I put in list 1, my Y values I put in list 2, and of course the mark here we can change around, choose a plus sign or just a dot. I'm going to use the boxes, nice, easy to see. What you want to do before you graph this, you want to go to Zoom. You want to go down to where it says Zoom Z Stat. Once you do that, you hit enter, and it graphs it for you. So this is my actual scatter plot of this table over here. And of course, then we just label our axes. Of course, my Y is going to be ice cream sold per gallon, and then on the bottom it will be 1 through 12, and it will be the corresponding months. And as we look at this, we see that 10 of the months, it's pretty linear. You can see these are fairly grouped together. It looks like it has a positive correlation coefficient because the slope would be positive. But you have these two outliers right here. So we're done with number 3. Now we're going to go on to number 4. It says write an equation and graph the linear regression line for the data. Well, we're going to let the calculator do this for you because doing a linear regression by hand is just brutal. So it's really straightforward on the calculator. You're going to go ahead and hit stats. You're going to go over to calc, which is calculate. You want to go down to where it says linreg, right here, number 4. That means linear regression. You want to hit enter, and if you see in here it says X list. My X values is list 1. My Y values is list 2. Don't change anything else here, and you just want to calculate. Now, okay, so now here we have y equals ax plus b. You're used to seeing the form as y equals mx plus b, but they just changed the letters on you, a and b. A is going to be your slope, b is still your y-intercept. Our correlation coefficient with those outliers is a 0.68, so it's not really a very good fit, but if you exclude those outliers, it would be a pretty good fit. My equation would be 0.12, if I just want 2 decimal places, 0.12x plus 9.05. Make sure you round because 6 is right here, so this would go up to 5. Over here, this 2 would stay because the next number is 0, and we keep the 2. So this is great. Now that we have the equation, the last part is to use the linear regression. Well, actually, that one wants you to actually graph the line. So here's what we do on the calculator. We're going to go to y equals, because if you have an equation you want to put in y equals, you don't have to write it down. The calculator has it in its memories. You can actually go to vars. We want to go to statistics, stats, so we're going to hit 5 or scroll down to it. EQ, we're going to go over to EQ for equation, and I can either do A, just the number A, B that it has, or the regression. Well, we already did the regression, so hit enter, and it puts the equation in for us. And then if we go and graph it, there we have our best fit line, our linear regression line, with our outliers. Now, from here, pretty straightforward. And of course, you draw this by hand. Number 5 says use the linear regression line to predict the number of gallons of ice cream sold when the temperature is 78 degrees. So here's a nice little trick that the calculator will do for you. You can go to vars. You want to go second mode, which will quit. Go to vars. Scroll over to y-vars. Of course, this is a function because we're in y equals. We put our function in y1. So if you hit enter there, open your parenthesis, and it wants 78 degrees. So we put in 78, close my parenthesis, hit enter. What you did right here, you're telling it to put 78 in for x, or in my function y1, which is our regression. Therefore, we can predict, we can do an interpolation of if it's 78 degrees outside, they would actually sell about 18.4 gallons of ice cream. I know this problem, you have to go ahead and do it on the calculator, but I also want you to do everything by hand except the regression.